Hi, welcome to Unit 2.3, Solutions Chemistry. This is part 3 of 3. This is the final part. As with the other sections, you also need to make sure that you watch the supplemental video. And let's begin. So the purpose of this part of Unit 2.3 is for you to learn or just get an understanding of why it's important for us to know conjugate acids and conjugate bases. And before we get into that, though, we need to just review acid and base strength. As you probably recall, we can measure acid and base strength using a pH scale, and the lower the pH, the more acidic it is, and the higher the pH, the more basic it is. Okay, now why is that? It all has to do with the fact that pH is equal to the negative log of the concentration of H+. And the more acidic something is, the more H+ ions it will have in solution. So the more acidic, the more H+. Now, since pH is negative log of the concentration of H+, with that negative there, as the concentration of H+ increases, pH decreases. So that's why at a lower pH, it's more acidic, because that means that you do have more H+. On the flip side, the more basic something is, the less H+ that you have floating in solution. So the concentration of H+ decreases, the more basic it is, and the concentration of H+ increases, the more acidic it is. Okay, so what's that have to do with conjugate acids and conjugate bases? It turns out that the stronger the acid, the weaker its conjugate base. So here, if you look at this diagram, at the top we have a strong acid like HCl, and then on the side, in terms of on the base side, Cl minus, its conjugate base is weak. And we can tell that because the way that this scale works is on the acid side, which is shown here in red, acid strength increases going up. And on the base side, shown here in blue, base strength increases going down. So HCl is a strong acid, its conjugate base is weak. On the flip side, the stronger the base, the weaker the conjugate acid. So let's take something like OH minus, so that would be like sodium hydroxide or potassium hydroxide, any of those strong hydroxide bases. The stronger the base, the weaker the conjugate acid. So here we have OH minuses, which are in the fairly strong zone. And when you look that over on the flip side there, its conjugate acid is water. And water, we don't even think of an acid to be an acid. Although it can act as an acid, it can donate a proton. And we notice that water is a weak acid because it's low on this side of the chart. Okay, so the idea is the stronger the acid, the weaker the conjugate base. The stronger the base, the weaker the conjugate acid. So the question may be like, well, why is that correlation? Like, why would a strong acid result in a weaker conjugate base and a weak acid result in a stronger conjugate base? What's going on? So what you're going to do is you're going to watch this video. You're going to watch the first 5 minutes, because believe me, after that, it gets pretty weird, but maybe you're into that. So watch the first 5 minutes, and then you're going to look for the relationship between strength and favorability of the reaction. So favorability means the desire of a reaction to go in the forward or the reverse direction. When you are done, we're going to come back together and finish this up. Okay, so here's something that you saw in the video. I just want to sort of recap something that you saw, which is the stronger the acid, the weaker the conjugate base. And that's because the weaker something is, the less reactive it is. HCl is strong, so it's a stronger, it's reactive, and that means the forward reaction is more favored, and most of the HCl ionizes. Cl minus is weak, so it's not reactive, and the reverse reaction is less favored, and very little Cl minus recombines with H+ to form HCl. So what does this all say? Remember, you said, as you mentioned in the video, even though we show strong acids as completely ionizing, the truth is it's not 100%. So he showed here, like, this would be 1% of this left and 99% of it ionizes. And so what that means is going from HCl to H plus and Cl minus is a favored reaction. So I drew it with instead of drawing the arrows of the same size, I drew the forward arrow much larger than the reverse arrow, just to show that this forward reaction is more favorable. Like this really wants to happen. And that's because HCl is a strong acid. So strong things are very reactive. So they're going to react a lot. And so they'll produce, you'll have mostly the H plus and Cl minus products. The reverse reaction, when Cl minus is acting as a base, so this conjugate base here, it's weak. So because it's weak, it's not really going to do much reacting with the H plus. A little bit of it will react. And so I drew that with a teeny tiny arrow to show that this happens just a little bit. And that's because it's weak, so it's not very reactive. Now, this may all seem kind of like, okay, so I still don't really understand the point. This is a great preview for equilibrium, which is one of the fundamental tenets of chemistry, understanding equilibrium. And this idea of one reaction, the forward or the reverse, being more favored than the other based on the strength of the reactant or the weakness of the reactant is something that is super useful. So at any rate, this is why we sort of learn conjugate acid and conjugate bases, because it sort of helps us to also understand that. Alrighty, I hope you found this video helpful. That's it for the 2.23. Have a quality day.